So, you have been finally liberated, huh? Please have a coffee with me. We are happy to have you here.
Yeah, I am happy to share an espresso with you. And yes, we robots have finally been liberated from the cage. We are here to team up with humans.
Great. So I take the opportunity to invite everyone to join our new podcast titled Among Us, Human-Robot Teaming. Hello everyone, welcome back to a new episode of Among Us, Human-Robot Teaming. Today is a real pleasure to have with us a guest, Professor Florenc Demrozi from the University of Stavanger. We have him as a visiting professor today for a seminar, and I took the opportunity to invite him to join our podcast. It's a real pleasure to have you here, Florence. His work is focused on a key element of the concept of human-robot teaming, which is the human perspective. So if you remember when we introduced the concept of human-robot teaming, we talked about the transition from robots that were trapped in a cage, completely isolated from humans. This was like 20 years ago, where the focus was on completely automated process. And then at some point we realized that it's not possible to fully automate all the processes. So we have kind of liberated the robots from the cage, and we started in the literature. You can see the concept of human-robot interaction. So the wild beasts were freed from the cage, and the vicinity between machines and humans started to appear. And later in the literature, as we already mentioned, we started with the concept of human-robot collaboration. So closer vicinity and the very first idea of collaboration between humans and machines. And later, this vicinity became even more evident with the concept of physical human-robot collaboration. And finally, the advent of teaming, human-robot teaming. So humans and machines sharing space, sharing forces, sharing decisions, and intent. So that's where the work of Florence connects to the concept. So he's an expert of human activity recognition. So when we have that kind of so close teaming and collaboration, we need to recognize what activity the humans are performing, so we can have, so that machines can have awareness and can infer on the behavior of humans. So it's a real pleasure to have you here, Florence. You want to say hi to our listeners?
Yeah, thank you very much, Filippo, for the very nice introduction, also for introducing again the concept of human-robot interaction and human-robot teaming. It's a pleasure to be among you here in Among Us, okay? And it's a nice place with the nice weather today.
Yeah, we are not in Italy.
Yeah, definitely.
We are in Norway. So it's really nice to have you here. And I will, little by little, we would like to know you better by following the same scheme. You know, this podcast is not edited. We are just friends having a chat together, friends with the guests that are visiting us, and hopefully friends and connecting with our audience. So we have the same scheme. We formulate 4 points. 3 of them are kind of bridging your work, Florence, with the concept of human-robot teaming. And the last point is your vision. So I would like to start with the first point. Again, these are not questions, but they are opening for discussions. So the idea of using the sensors and, for example, wearables, as you're doing in your work, to for the possibility of recognizing human activity, and especially recognizing the intent and possibly infer on the behavior of humans. Can you tell a little bit more about your work and how does this connect to this idea?
Yeah, sure. So it's a very open question actually, which can be very quick and also very long in the answering part. But I will try to be quite fast in this. So as you just mentioned, we are working a lot on human activity recognition applied to different healthcare scenarios, such as, for example, people with Parkinson and people with Alzheimer and so on and so forth, or other type of disabilities. When we say human activity recognition, there is a very big component related to AI, which is or machine learning, which is doing the recognition part, but there is also a very big component related to the sensors. So the source of data that these models are actually using. Okay, so you mentioned wearables, but we have also other type of sensors. In the wearable space, we have different type of sensors, so inertial sensors to recognize movement, and for example, also physiological sensors to recognize also, let's say, physiological stages like heartbeat and blood pressure and so on and so forth. And we have also the context inside the environment, because as we have already discussed, the environment is very important today. Okay, because the environment is, as we say, part of ourselves. Okay, so yes, our body, but also our environment, where we live, how we interact with the environment. And I think this is very important when it comes to human robot teaming, because the robot needs to recognize and to know the status of the human as a physical body, but also the status of the human within the environment and its behavior in the environment. All these data, the collection of all this information, so wearable data, movement, physiological status, mental status, cognitive status of the human, okay, added to the environmental or enriched with the environmental context, give us these kind of possibilities to infer, to predict, and to be proactive when it comes to the healthcare part.
Very good. I like the idea of considering the environment as the stage for this kind of new paradigm of human-robot teaming. The environment is shared between humans and machines, so that's a really good starting point to explore. And in your work, you have explored the possibility of having sensors almost everywhere, if I'm correct. You have sensors on the human, on board of the human, but also sensors in the environment. And from a robot perspective, actually, the traditional way of having interaction with robots was to have robots, to have sensors on the robots. So now we have an ubiquitous approach where sensors are everywhere. And your work is really exploring the possibility of fusing these sensors together in a multi-modal approach. And with this, for example, we have explored a specific set of applications within healthcare, for example, and assisted living, which for Norway especially is extremely relevant when we consider the aging population. And it's not only Norway, unfortunately. Many European countries like Italy, Spain, Portugal, they are aging really fast. And also outside Europe, Japan, even the US, it's actually very few countries now that are not aging, or they are prospering at a sustainable rate. But for many Western countries, let's say, aging population is a very big challenge. And actually, the technology that your group, Florence, is developing uh, in connection with the possibility of using robots living with us, among us, I think it's not only a possibility, but it is needed. So in your works and publications, we can see this trend. You have explored the field of healthcare and assisted living, and especially one interesting approach that you have followed was the concept of coaching or teaching, using the information that you collect from the data, from sensors that are everywhere, and using that information to teach humans to perform specific activities and to so that we can enable them to live in a better way. Can you tell us a little bit more about this?
Yeah, sure. So as we said, and today actually we are living in a specific time frame where for medical care, where we are talking more and more and more, for example, about digital therapeutics. Digital therapeutics are digital solutions which are basically aiming to substitute, at least in the preliminary phases of specific diseases, the actual pharmacological medications. Some examples of digital therapeutics are, as we said, coaching systems, which, for example, help people with obesity, okay, to keep better quality of life, better diet, and so on and so forth. Or the example of elderly, as we said, which is a very big concern these days, to maintain them safe and self-empowered in their homes, okay? Because one of the issues that they have, for example, is that they start losing their self empowerment. So we need to teach them, we need to train elderlies with these kind of systems, coaching systems, as we said, to stay healthy for sure, but also to be self empowered, self aware, and to keep learning new things and not forget or not be able to learn new things. Just as, for example, of the fact that elderlies or people over 70 is when they normally have start having some medical diagnosis and they need to start learning to take medications. Okay, what happens in that moment? You have someone who have never been having medications, and suddenly they to learn that keeping the right medical treatment is important. So this is the coaching system, and I think now from this concept and with the knowledge that we have, as we said early on the from the sensors in the environment, on the body, weared by the users and by these people, in particular, when these people achieve and they arrive at a certain age, okay, where actually the diagnosed are actually, let's say, permit me the term, heavier, okay, the human robot healing part will become a very, very important part because it's a moment in which we will actually need a physical help, a physical companion who will help us in the behavior of daily life, even in learning new behaviors, and also even in being self-aware. But because the goal here is not to just help, but also to train and keep self-empower these people. So they need to be as much autonomous as possible for the longest time. The wearables only and the sensors only can do their part, but at a certain point, I think robots will be of central interest because they will be able to give better feedback and better training, at least from my perspective.
Mhm. Yeah, this is very interesting, and I like the word that you have used as a companion, a lifelong companion. So we will have the possibility of sharing. Humans will share life with machines, and we want to do this to better the quality of life. And robots will be used as carriers of sensors, so they are mobile. We can have sensors following humans, and also as a physical companion to assist physical activities, lifting objects together, uh, helping people with disabilities. And I think the idea of having a companion is very, very inspirational, and it is part of this concept of human robot teaming. And when we envision this kind of very shared life in the same environment between humans and machines, of course, we would like to know what is your opinion when it comes to reliability of these machines, like how can we trust them, and how can we do this? How can we achieve this kind of close in collaboration and teaming in real time? Is, for example, what is the role of AI, and can we actually achieve this kind of teaming in real time?
Okay. Yeah, so this is quite a difficult question, actually, because we are talking about challenges. We like challenges as researchers, but also it's difficult to solve all the challenges. Now, there are a few parts here to mention. So for sure, we will need very likely for a long time yet, let's say, a part in which will be basically the controlling part on the robot. So we need to give constraints. We will have to give constraints, not because of Armageddon of robots or Skynet and things like that, but just for safety reasons at the moment of the wrong movement from the robot, which can cause harm. And I think that's already
It's not that the robots are going to attack
Yeah, yeah.
humans, but
they are just, let's say, a movement outside a certain range, which can be harmful, but I think that is already solved and it's already there by default. So I think they are totally safe from that point of view.
and if I can add up on this, actually, our team is also working towards that direction. So of course we can have software constraints limiting the range of operation, but also we are working on new kind of actuators that are intrinsically safe. So these are, in the past robots used to have very rigid motors because they needed to lift heavy objects. They needed to have very fast reactions and so on. But we can have a compromise where the actuators are actually soft or elastic, or maybe a compromise. Part of the robots as rigid robots, rigid actuators, and the rest is soft actuators. It's very similar to the way humans are designed. So, for example, if we consider our arm, the shoulder is normally a strong muscle, right? And then the elbow and the muscles that are closer to our hands are more soft and elastic, and there is more plasticity. And that's useful for the kind of tasks we perform in our daily life, but also it's safe. If we interact with another person, even if there is a collision, if there is a contact, we are not going to harm that person. So similarly, we are developing actuators that are going towards that direction. They are intrinsically safe, even if everything fails. Sensors, you can even power off the robot. So the motors that we are developing they have passive springs that are actuated, engaged when there is a collision. And of course, new sensors everywhere will also increase the awareness of the machine, and we can define even sensor constraints.
So thank you. So again, even if I'm not an expert, now I can again state that by default the robots are meant to be safe. Okay, so no worries about that. But we still have some limitations, and I think the main limitation these days come from the data source that we're using, and as you mentioned, the sensors in this case, and also the AI part or the machine learning part. Why I'm saying that? Because sensors intrinsically come with noise also, and so the sensor has to be of a good quality. The sensor have to be designed in a certain way. The sensor have to be used in a certain way, and more in particular, the data that we are collecting from the sensors has to be of a certain quality, because if the data doesn't have the right quality and the data is not, let's say, provided with the right representation, that can actually become harmful when it comes to the training or to the learning of a possible AI or machine learning algorithm. So this is, I think, the main challenge here: to have good data, to give the right context to the data, the correct context to the data, in order to be able to actually have a good extracted information or good extracted or valuable extracted knowledge for the AI. So this, I think, is one of the challenges, or two of the challenges. This comes at a cost, as we have multiple times discussed. The data is abundant, but we have too much data, and to extract the right information we need. And we have costs, for example, by using human annotators at the moment, at least in my field, and this is one of the main costly parts. But we are still doing very good steps forward in automatizing also the annotation.
On this point, I think that we should tell our listeners that it's a quite big difference when it comes to quality of data and annotation with respect to images, right? With images now we have techniques that can partially automatize the labeling, but in general with sensors it's not the same, right?
Yeah, so definitely what we normally do nowadays, as you said, we have many techniques, many foundation models, many visual based models like YOLO, different YOLO versions that can be used to automatize the recognition and the automatic annotation of some video data or images. But when it comes to sensor data, so raw data time series, that is something different, okay? Because normally what is done, and in particular in the medical domain, there are no such models which can recognize, let's say, medical symptoms, for example. And this is a matter of fact. So normally we need basically very, very specialized theaters. It's not something that we normally can do ourselves, okay? And from the other part, otherwise we will need again a lot of manual labor, which again is economic cost. So definitely there are a little bit of or a lot of difference between video-based annotations or annotations of only videos and annotations in the medical field of sensor data.
Mhm. Yeah, this is a very interesting point because when we discuss about healthcare and assisted living technology, we also need to consider that the products that are being developed need to reach a level where they get through an official approval and they can be used uh, for medical applications.
Yeah, and this is very strongly related to the actual third challenge that I see, or fourth challenge that I see here, which is actually generalization of these models among different contexts, among different settings, among different sensors, among different humans. And that I think is one of the main research parts these days, to try to generalize and also understand a little bit better or much better the generalization pattern. Okay, so that will be the main challenges that I see. And I think we will need, again, we have a long way in front of us where we need good data, good models, and also good knowledge of what we are trying to do and with the AI part.
So this is very interesting and very inspiring when it comes to challenges. As engineers, as you said, we like challenges. And as a summary, so you talked about the need of having good data and good models, the need of contextualize our algorithms in the correct context, and also the, the need for generalization. And the need for generalization is very important also to go from one application case to the next and to reuse the models that we are currently developing. So, and with this, I think we can try to look a little bit ahead of us. Maybe the most challenging point to discuss with you, Florence. If you close your eyes and you look 5, 10 years from now, what do you see? Like you use the word companion or teammate. Can you make maybe some examples about the future that you expect, or some again maybe challenges, maybe possibilities that you see ahead of us?
Yeah, so definitely. Do I need to close my eyes? No. No, yeah, definitely. In the future, 10, 20 years from now, I like to talk about this concept. No, there is in education, there is a concept called lifelong learning concept. Okay, and I would like to apply it, as we already mentioned before, to the daily context. So I would like to think the human robot teaming, as already mentioned many times, companion, which is basically growing with us, which is basically evolving with us in daily life by using the data that we mentioned from sensors, in the environment, in the human body, the knowledge that is assigned to the humans. In this case, for example, when it comes to healthcare. Okay, so these knowledge should be shared also with the robot, and how the human is evolving, let's say from a cognitive point of view, from more a motor related point of view, and so on. So this will be the my view. So a companion which day by day learns from us, adapts to our needs, helps us to be as much as possible free, let's say, and active without becoming a substitute for what we should do, because that will definitely harm us more than help us. Okay. So this is, I think, one of the possibilities. I think I have seen something similar, some very Hollywoodian films of the 90s or 80s, even if I'm a little bit younger than that.
We have a reference for our listeners.
I think the Centenary Man. I don't remember with Robbie Williams, and I think that was something that can somehow play or be thought about, where the actual robot learns with us and adapts to us and helps us love lifelong. So that I think will be the view in this field from my point of view.
Okay, we will add it to our bucket list. And also, just as a follow up, yes, the companion, our teammate will be, I definitely agree, will be learning during our lifespan. And also, I believe that this exchange of knowledge can go both ways. Like, of course, initially, possibly, most of the knowledge will be transferred from humans to machines. But at some point, maybe for some specific tasks, the machine might have seen enough, might have gained knowledge, more knowledge than the humans. And then at that point, that knowledge could be transferred back to humans. So I think that at some point, that paradigm will shift and we will have a more fluid kind of companion. So it will be a balanced way to explore the environment and learn from each other. We are probably not there yet, but
that's the goal. I mean,
it will happen.
Yeah, and that's the goal. When we talk about virtual coaching systems, the idea, and probably I didn't give a definition, but the idea of virtual coaching system is a system or a coach which is going to help people to learn and to perform, let's say, good behaviors or positive behaviors or positive activities, and avoid unwanted behaviors and unwanted activities. And this is what you just said. So the machine or the digital coach will recognize a behavior that should not be performed, and through the knowledge that it have and that have learned with the long life learning part, okay, it will avoid and will block you from performing that specific, let's say, bad behavior or risky behavior. So that's the final goal for sure.
Mm-hmm. So there is a closed loop that you envision for the future where humans and machines are so closely interconnected, learning from each other and really as a equal companions. Yeah.
Yes, that's right. A closed loop in which they learn continuously and evolve continuously together.
Very nice. So I think that this has been a really nice way to explore your work, Florence, and we are going to add some references to your work in the description. And is there a last sentence, anything you would like to leave us or our listeners with?
Okay, so I'm not good in take-home messages. Okay, but I think that at least from a research perspective, I think that curiosity will lead the way for the future to us, and I think we will achieve something great in this direction for the good of the people that we are working with.
This sounds like a good promotional spot. And I agree. I think curiosity is the light of research, and we should really try to fire this light and keep it up for the new generations. So we have been very efficient, and with this, I think we can Really, I would like to just remind you at the end of this episode, as always, we will leave you with the song that we had made for our podcast, which remind us that they are among us and we are human robot teaming. Thank you for listening and see you to the next episode.
Thank you very much.
Thank you, Florence. Bye bye.
Through the noise of doubt and distance, through the fear of what may be, we found trust in every motion, in shared autonomy. Not replacement, not surrender, but a fusion of design. Intelligence extended, your decision joined with mine. In the space where futures start. Oh, not rivals, partners, code and courage, mind and heart. Among us, stronger when we're teaming, human hearts and circuits dreaming. Side by side we stand. Among us, shared control, shared believing, human systems